The air civilian engineer Robert Philo is breathing will kill 7 men in the next 14 hours. But right now, in the battery compartment of USS Cochino, he's trying to calculate something the Navy never planned for. How long before invisible hydrogen reaches the spark threshold? 120 miles north of Norway, beneath Soviet radar sweeps, the first rule of submarine emergencies has just become impossible. You cannot surface during a spy mission that officially doesn't exist. The bulkhead is warm. Gas hisses through deck plates designed to contain seawater, not chemical decomposition. His crew doesn't know the ventilation system had been failing for hours. They don't know the sister sub shadowing them has already made a calculation about acceptable losses. Philo knows the mathematics of battery explosions. He knows the ocean temperature at this latitude. What he doesn't know, what no one will know until the swells reach 20 feet and men start crossing between vessels on a cable, is which decision the Navy feared more: losing a submarine or losing what Cochino recorded in Soviet waters. The pressure gauge needle trembles. Someone needs to make a choice that hasn't been authorized. August 25, 1949. USS Cochino, a World War II Guppy-class diesel-electric submarine, runs submerged beneath Soviet radar sweeps. Her antenna mast is raised to intercept Soviet naval radio traffic from bases along the Kola Peninsula. This is signals intelligence collection, classified at the highest level. Commander Rafael Benitez commands the boat. He enforces strict radio silence because any transmission or emergency call will expose American eavesdropping operations to Soviet direction-finding stations. The mission pushes Cochino's crew and equipment to their limits in the unforgiving Arctic waters. While the submarine's batteries had been upgraded from their World War II predecessors, these newer, high-capacity cells were volatile and temperamental, particularly under the relentless demands of Cold War espionage operations in freezing conditions. Chief Engineman Robert Philo monitors the forward and after battery compartments. His crew logs voltage, temperature, and specific gravity every 30 minutes. The batteries consist of lead-acid cells stacked in wells beneath the crew spaces. During discharge, they release hydrogen gas as a byproduct of the electrochemical reaction. On a normal patrol, the submarine surfaces after a few hours, opens hatches, and blows fresh air through the compartments. Hydrogen disperses harmlessly into the atmosphere. But Cochino cannot surface. Benitez has orders to remain submerged for the duration of the intercept window. Philo watches the hydrogen readings climb. The ventilation blowers can only recirculate air inside the pressure hull. They cannot expel gas overboard while the boat is sealed. Commander Benitez knows the risk. His orders come from Atlantic Fleet headquarters and are marked top secret. Cochino is collecting evidence that Soviet naval radio communications follow predictable schedules and frequencies, intelligence that will shape NATO submarine operations for the next decade. Surfacing now would trigger Soviet radar alerts and compromise months of planning. The mission requires complete stealth. Benitez calculates that the batteries can sustain another 2 hours of submerged operation before reaching critical hydrogen levels. He decides to continue. Below decks, damage control efforts intensify as the crew works to manage the worsening battery conditions. The crew does not know the full stakes. They know only that this patrol is different, longer, and that the usual safety margins no longer apply. Deep into the submerged run, dangerous hydrogen readings are detected in the battery compartments, levels higher than safety protocols allow. Standard doctrine calls for immediate surfacing. Open the main hatch, blow fresh air through the compartments until hydrogen drops below 1%. But Benitez faces an impossible choice. Daylight exposes the submarine to Soviet patrol aircraft, and breaking radio silence to call for extraction would confirm American espionage activity. According to available records, initial warnings of the gas buildup reach the control room. The situation escalates rapidly. Hydrogen continues to accumulate near the overhead, invisible and odorless, pooling in spaces where any electrical spark could ignite it. The submarine's ventilation system is a closed loop while submerged. Blowers push air through ducts that run the length of the pressure hull, but every cubic foot of air circulates inside the same sealed envelope. Hydrogen, being lighter than air, rises and collects against the overhead in the battery compartments. The only way to remove it is to open hatches to the outside atmosphere. That requires surfacing. Philo knows the physics. At 4% hydrogen by volume, the mixture becomes explosive. Any spark from a relay, a tool striking metal, or a frayed wire will provide enough ignition energy to trigger combustion. He calculates that the forward compartment will reach 4% within 2 hours if discharge continues at the current rate. Benitez faces a choice, with no middle ground. Abort the signals intelligence mission, surface in daylight within range of Soviet radar, and ventilate the battery compartment safely. Or continue submerged, complete the intercept window, and accept the risk that hydrogen will reach explosive concentration before the mission ends. Fleet intelligence has made clear that this intercept opportunity will not repeat. Soviet radio schedules will shift once they suspect American submarines are listening. The data Cochino is collecting will guide Allied submarine deployments for years. Benitez decides the mission is worth the risk. He orders his engineering crew to reduce electrical load and extend battery endurance as long as possible. The submarine remains submerged. The clock continues. The command orders non-essential electrical equipment secured. Galley ovens, water heaters, and ventilation blowers in berthing spaces are shut down. The crew shifts to minimal lighting. Every amp saved extends battery life and reduces hydrogen generation. But the classified radio intercept gear cannot be powered down. It is the reason Cochino is here. The receivers, recorders, and direction-finding antennas draw continuous current. The batteries continue to discharge. Hydrogen continues to rise. The submarine's crew moves through the compartments with flashlights, checking for loose connections or worn insulation that might arc. One spark is all it takes. The boat grows colder as heating systems go offline. Condensation thickens on the bulkheads. The crew works in silence. At approximately 10:48 a.m. on August 25th, nearly 14 hours before she would eventually sink, a muffled thud echoed from the after battery compartment. Crewmen in nearby spaces report smoke and the acrid smell of burning insulation. Robert Philo, a civilian sonar technician on board, assisted as the crew fought to contain the gases. The compartment is hazy. Temperature readings on the battery cells are climbing. The source is identified in the after battery well, where seawater and electrical shorts are causing a violent reaction. Salt water is contacting the lead plates inside, driving a secondary reaction that generates additional hydrogen and releases chlorine gas. The ventilation system cannot clear the smoke. The compartment is evacuated and the situation reported to the control room. Benitez now faces a new crisis: fire and gas in an enclosed space with no way to vent. Under the direction of Lieutenant Commander Richard Wright, the crew attempted to secure power to the forward battery compartment. An electrician opens the main breaker panel to isolate the damaged cells. As the breaker lever moves, an electrical relay in the overhead arcs. The relay has been cycling on and off for 14 hours, and salt spray from the leak has corroded the contacts. The arc releases a fraction of a joule of energy into air that is now over 4% hydrogen. The compartment detonates. The pressure wave blows the access hatch open, shatters deck plates, and ruptures the forward trim line. Seawater and battery acid flood into the bilges. The lights go out. The main motors stop. Cochino loses all power and wallows dead in the water as Arctic swells build around her. The explosion severely damages the after battery switchboard and ruptures feed lines throughout the compartment. Seawater floods the battery wells, shorting the remaining cells. Salt water conducts current between the plates, generating heat and releasing chlorine gas. The entire electrical plant goes offline. Without power, Cochino cannot run her ballast pumps, trim the boat, or drive the main motors. She wallows on the surface, taking on water forward, unable to steer or make way. The storm is building. Swells are reaching 20 feet. The nearest help is USS Tusk, a sister submarine trailing as an escort. Benitez breaks radio silence and calls for assistance. The spy mission is over. The fight for survival has just begun. Lead-acid batteries release hydrogen when abnormal conditions cause water to electrolyze at the negative plate, typically during charging, overcharging, or when internal faults create localized current flows. The reaction splits H2O molecules, releasing hydrogen gas and leaving oxygen bound in the electrolyte. In a sealed or poorly ventilated compartment, hydrogen rises because it is 14 times lighter than air. It accumulates near the overhead, displacing oxygen and forming a layer that grows denser with every hour of abnormal operation. At 4% by volume, hydrogen reaches its lower explosive limit. Above that concentration, the mixture will ignite if any spark provides at least 0.02 millijoules of energy. A relay closing, a tool striking steel, or a frayed wire brushing a bulkhead is enough. Combustion releases 286 kilojoules per mole, generating a pressure wave that propagates faster than the surrounding air can move. The explosion blows deck hatches upward, fracturing the latches and seals that keep the battery compartment watertight. The pressure wave ruptures trim and drain lines running beneath the deck plates. Seawater floods into the battery wells. Salt water is an electrolyte. When it contacts the lead plates still holding residual charge, current flows directly between the plates without passing through the external circuit. The cells short internally. The reaction generates heat, boiling the electrolyte and releasing additional hydrogen and chlorine gas. Chlorine reacts with moisture in the air to form hydrochloric acid vapor, which corrodes wiring insulation and exposed metal. Every electrical system in the flooded compartment is destroyed within minutes. With no power to the ballast pumps, damage control parties must hand pump the flooded spaces. But the boat is taking on water faster than the pumps can expel it. Damage control parties rig emergency hand pumps and drag hoses to the fire. Freezing seawater is the only firefighting agent available. They pump it onto the burning insulation and smoldering wiring in the after battery compartment. The water extinguishes the flames, but corrodes every circuit it touches. As seawater mixes with battery acid, the corrosive environment causes rapid oxidation of electrical components. Copper bus bars likely turn green. Wire bundles short together. The electrical damage cripples the boat's ability to maintain trim and buoyancy. Cochino can no longer control her angle or depth. She remains on the surface, settling by the stern, listing to starboard, rolling in the swells. The crew works in near darkness, breathing through rags soaked in fresh water to filter the chlorine vapor. Every hour, the boat settles deeper as more water accumulates. On the morning of August 25th, following a catastrophic battery explosion, Benitez orders an emergency surface. Cochino breaks through to the surface, but she cannot dive and cannot make way under her own power. The main motors are dead. The batteries are flooded and shorted. The storm has intensified overnight. Winds are gusting to 40 knots and swells are running 20 feet. Benitez transmits a distress call. USS Tusk, trailing 10 miles astern, turns toward Cochino at full speed. The two submarines rendezvous in the Norwegian Sea, 120 miles north of the nearest safe harbor. Tusk commander, Robert Worthington, maneuvers alongside. The plan is to transfer pumps, emergency power cables, and personnel. But the seas are too rough to pass lines. According to survivor accounts, the only option is a perilous transfer. Men crossing between the two heaving hulls on wooden planks and lifelines. Tusk edges closer. The gap between the two submarines narrows to 15 feet, then 10. Waves surge through the space, lifting and dropping the hulls with multi-ton impact force. Tusk volunteers line her deck, ready to cross with pumps and damage control gear. Men begin transferring across the treacherous gap. According to survivors, several make it safely to Cochino's deck in the initial attempts. Then, disaster strikes. Historical accounts describe a massive rogue wave surging between the hulls. The wave catches men on Tusk's deck, sweeping them into the freezing water. In the chaos, hulls slam together with crushing force. Men struggle in the water between the submarines. Some are pulled under. Others vanish into the gray Arctic swells. The transfer halts immediately. By the time the rescue attempt is suspended, 7 men have been lost to the sea. Cochino continues to flood. Historical accounts confirm major flooding in the engine rooms and after compartments. The after compartment is taking on water through cracked seals and ruptured ventilation trunks. The damage control crew rigs collision mats and stuffs blankets into the leaks, but the boat is settling by the stern now. Benitez orders all non-essential personnel to transfer to Tusk by life raft. 76 men climb into rubber boats and are pulled across the gap. A skeleton damage control party remains aboard, still trying to slow the flooding. But the pumps cannot keep up. At 08:30 on August 26th, the stern slips under. The bow lifts out of the water, vertical against the gray sky. Commander Benitez and the remaining crew leap into the sea. Moments later, Cochino disappears beneath the surface. The only man lost from Cochino's crew was civilian technician Robert Philo, swept overboard hours earlier during the rescue operation. 76 men are pulled from the water and brought aboard USS Tusk. But the mission's highest casualties come during the rescue itself. 7 men are lost. 6 Tusk sailors who volunteered to cross over and help, and 1 civilian technician from Cochino. Some are swept overboard in the violent seas. Others are crushed during the desperate transfer attempts. 7 men who didn't have to be there. And then, silence. For 50 years, their sacrifice is buried under classification. The Navy tells the public Cochino's loss was mechanical failure, nothing more. The signals intelligence mission, the Soviet intercepts, the operational constraints that trapped the crew, all of it remained secret until 1999. The casualties included civilian technician Robert Philo and Tusk sailors John Callahan, Dean Cummings, John Guttermuth, John Shelton, Harold Taylor, Robert Thompson, and William Whitehead. Hidden for half a century. But their story isn't over yet. Benitez sits across from the investigators, salt still crusting his uniform. Every crew member who worked the battery compartments gets called in for questioning. The question hanging over all of them? Whose mistake was this? The inquiry's findings get stamped classified. But someone has to answer for the men they lost. Within 6 months, the Navy tears apart the Guppy-class ventilation system. New ducting gets installed. Hydrogen can now vent overboard through snorkel masts while submerged. No more gas building up in silence. Continuous hydrogen monitoring becomes mandatory on every diesel-electric boat in the fleet. Battery discharge protocols get rewritten, limiting how long older lead-acid systems can push underwater. The changes roll out across the entire Navy. Battery explosions had killed submariners on multiple boats during World War II. In the decade after Cochino, those casualties drop sharply. The engineering lessons become part of the Navy's institutional knowledge. But the mission that cost 7 men their lives? That story stays classified for decades. 7 men dead in the Norwegian Sea. And for what? The Navy's response focuses on what can be controlled. Battery safety, snorkel design, the technical failures that doomed Cochino. New procedures, better equipment. Submarine tenders repositioned closer to Cold War patrol areas. Cut the response time. Cut the distance between a crew in trouble and someone who can reach them. But the high-risk rescues? The line transfers in heavy seas? Those remain part of the job. The Arctic patrols continue. The Cold War doesn't pause for safety. The technology that might have made a difference, deep submergence rescue vehicles capable of mating directly with a stricken submarine's escape hatch, that won't arrive until the 60s, spurred by another disaster. 1971 brings the first operational DSRV, but it's built in response to Thresher, not Cochino. Lessons are learned. Lives will be saved by those lessons. But they come too late for the 7 men lost in Tusk's rescue attempt. For 5 decades, the Navy's official report attributes Cochino's loss to battery failure and flooding. No mention is made of the signals intelligence mission, the Soviet intercepts, or the operational constraints that prevented emergency surfacing. Families of the dead are told their men died in a mechanical accident. The truth remains locked in classified files. In 1999, the Navy declassifies portions of Cochino's mission records. Investigators and historians piece together the full story. Cochino was not on a routine patrol. She was conducting Cold War espionage at the edge of Soviet territorial waters, collecting radio intercepts that would shape NATO submarine tactics for years. The mission was deemed more important than the standard safety protocols. The crew paid the price. Chief Engineman Robert Philo survives the sinking and continues his Navy career. He is awarded the Navy and Marine Corps Medal for his damage control actions aboard Cochino. The citation credits him with keeping the submarine afloat for 14 hours after the explosion, giving the crew time to evacuate. Philo retires in 1962. He rarely speaks publicly about Cochino, bound by classification rules that remain in force until the end of his life. When the mission details are finally released, historians recognize that Philo's calculations and his crew's discipline under impossible conditions represent some of the finest damage control work in submarine history. His actions bought time that saved 76 men. Cochino is the first United States submarine lost in the Cold War, and the only one lost on a classified espionage mission. Her sinking occurs less than a month after the Soviet Union detonates its first atomic bomb, escalating the nuclear arms race and intensifying the need for intelligence on Soviet capabilities. While the mission demonstrated the potential for submarine-based signals intelligence, historical accounts suggest the specific data collected on this run was limited before the accident occurred. Still, the proof of concept shapes American submarine operations in the Atlantic and Arctic for the next decade. The mission's success, measured in data collected, is never publicly quantified. But the cost is known. 8 men dead, a submarine lost, and a secret kept for half a century. Cochino rests on the floor of the Norwegian Sea in water too deep for salvage. Her exact position, 120 miles north of Norway, was recorded by USS Tusk and remains in Navy records. No attempt has been made to recover the wreck. The classified radio equipment aboard was lost with the boat. The fate of the intercept data remains uncertain. Some accounts suggest the mission succeeded in transmitting intelligence to Tusk, while others indicate the primary recordings were lost with civilian technician Robert Philo when he was swept overboard. Over the decades, research expeditions have explored the region, but the wreck's precise location on the seabed has remained elusive. Cochino remains where she sank, a Cold War gravesite known only to the families of the men lost and the historians who finally learned her story. She is remembered as the submarine that could not surface, the mission that could not be aborted, and the first price paid in a conflict fought in silence.